Hello everyone, this is Raida Hawk and I am presenting my submission for Physics 2211 Lab 1, which was on constant velocity. So the objective was to measure constant velocity motion and model it using the momentum principle. The overview. I recorded an object moving in a straight line, extracted position versus time data using tracker, and then constructed a computational model in CloseScript using the momentum principle. Finally, I compared the model prediction to the observed data to evaluate agreement. So here is the tracker video that I recorded where you can see that I used a marker and then I rolled it on the desk, and I did follow key instructions that were given, which was to keep the camera stationary and the object was moved across the screen rather than towards or away from it, and it had to be in a straight line. I also included a calibration object of known length so the tracker could convert the pixel distances into meters. I then tracked the same point on the object in each frame to extract time and position data. This is the graph that I received, where you can see that the measured x position as the function of time. The graph is approximately linear, indicating constant velocity. The slope of the line therefore represents velocity. The slope is decreasing, which shows negative velocity, but that is because in the video, as you can see, that the object is moving from right to left and the right has been considered as the positive direction. Because the slope remains approximately constant, the acceleration is approximately 0. And here are the physics models that I used. To model this motion, I applied the momentum principle, which states that the change in momentum equals the net force multiplied by the time interval. Since the observed motion has constant velocity, acceleration is approximately 0, which implies that the net force is 0. Therefore, in my CloseScript program, I set the net force vector equal to 0. With 0 net force, velocity remains constant and position evolves according to x equals x initial plus v times t. You can see a snippet of code from the CloseScript model that I used, where I initialized the object with an initial position of 0.157, which I received from my tracker model, and then I initially had set the velocity to 0.15 meters per second, but however then I noticed that the slope was positive and then it would not reflect the graph that I received in tracker. So then I changed it to minus 0.15. However, since the net force is set to 0, the velocity remains unchanged at each time step. The position updates linearly over time according to the constant velocity equation. And if you want to view the full model, you can visit the link given on the screen. The velocity versus time graph that I received is shown on the left, where you can see it's set at a constant value, and here is the model, which you can see replicates the motion of the marker horizontally on the desk. Finally, I extracted both the data from CloseScript as well as from tracker and put them onto Excel to plot it into a scatter plot. The graph compares the experimental tracker data with the computational model prediction. One thing to note is that they are plotted against the same time values and the two curves closely overlap, indicating that the zero net force model accurately describes the observed motion. Any small derivations are likely due to measurement uncertainty in tracking, calibration error, or minor frictional effects. Finally, we have the required questions and the assumptions that we used. First is, what if we flip the axis? If the x-axis direction were flipped, all position values would change sign and the velocity would change sign as well. However, the magnitude of the speed would remain the same. The physical motion does not change, only the coordinate description changes. Number 2. What does the net force equal to 0 mean? It means that the acceleration is approximately 0. However, from the motion data alone, we cannot determine how many individual forces are acting. We only know that the vector sum of all forces equals 0. For example, gravity and the normal force cancel vertically, and horizontally, any friction would have to be negligible or balanced by another force. Finally, what are the assumptions? The main ones are that the motion is strictly one-dimensional, the camera remained stationary, the calibration was accurate, and the net force during the observed interval was approximately zero. Thank you.